Hi, welcome back. So we are at the second outline to discuss procedural paradigm versus object-oriented paradigm. So what do we mean with the word paradigm? Paradigm is defined as the framework or the infrastructure of the solution that you are trying to create as the outcome or the product to solve a certain problem. Now, from programming perspective, we have these two different paradigms. One of them happens to be called as a procedural, and the other one, of course, the discussion of this training, the object-oriented. So we have decided to bring these two paradigms, one next to the other, in order to show you the actual advantages that object-oriented try to offer from the disadvantages procedural paradigm is offering. First of all, let's look at the exact definition of a procedural kind of a paradigm, what it is. It's actually the execute is step-by-step instructions and organizing code into kind of a procedures or what we call it functions. Now, let's take an example of that. If you would have to make a certain or baking a cake, for example, there should be kind of a recipe. And this recipe has a kind of a step-by-step telling you how to make a specific cake. So every time you want to make a new cake, you just go and pick up that kind of recipe and follow the steps one by one until the final product or the cake is ready. This is the analogy of that definition. On the other hand, when it comes to object-oriented, definition, it's to actually organize your code around what's so-called objects. And now you know what object is, which actually bundle two important things, the data and the behavior, or in other words, to say the attributes and the methods around it. Now, from analogy, again, perspective on the same example of making a cake, I want you now to imagine that each cake you produce, it has its own ingredients and baking methods. So it is not like one specific recipe you follow one by one. Still, perhaps this is a little bit vague to explain, but let me show you an illustration with a specific code from two different languages. So let's look at the first language, C. C is one of the fundamental kind of a programming language we teach usually and we learn at the very beginning of our journey. And C happens to be a programming language that actually built or written based on a procedural kind of a paradigm. In the contrast, we have Python, which is actually the focus of this training program as a programming language that support object-oriented paradigm. So let's look at a specific problem, and we wrote the code in both. Now, I don't want you to care too much about the code structure, but I just wanted to tell you the idea overall. Imagine we are writing a piece of code that is going to print a name of a student and the score of that student after this score has been calculated using one of these actually score letters as A, B, or C. Now, what happened in C language when we write this kind of scripts, now you don't have to bother too much about the structure of C language, but I just will tell you, we have this block called the main function, which actually the one it will be executed. And then inside there, you look at the functions that we are trying to do. So we're trying to do two important functions. Display, this is the verb or the behavior, the student's information, and two, to calculate the grade of the student. So we have the display function and you have the calculated grade function. So you have actually these two functions that are actually doing the main idea of the final product. Now, in C language, first of all, we use something called the struct to create this entity. Let me call it the student. So this has two particular attributes, just as the name of the student and the actual score in form of integer. Now, in the main function here, what we did, we just created one entity, a student with a specific name and specific score. However, when we wanted to actually display the information about this particular student, giving his score is 93 after we calculate, of course, the letter, we called another function, we call it display. So in the display function here, it does exactly what we wanted. It print the name and the score. However, it does something else. For the grade or the letter, it calls another function, which is in this case called calculate grade, etc. So at the end of running this program, you will get your expected result. You will get the student name, the score of the student, and the grade in letter student. Now, in the back end, what we're trying to say, these two functions actually work completely independent from each other. Now, if I would have to create a new student, a new struct of a student X, for example, with a new score, once again, I would be following the exact procedural aspect by calling the functions of calculating the grade or displaying the student's name or information. Now, here, the point that I wanted to make is to look at the word independent. So once again, these two functions completely independent from each other. Now, look on the contrast of using Python programming. So basically, we create what's so-called a class. And class is a very, very important. You will be having, more details on how to convert object into becoming a class. Anyway, so we create a class. We call it a student, and it has three important sections here. I want you to look at it. The first section, it's here. It holds the exact names of the details that we're talking about, like the name and the score. But we have these two methods inside, and I'm calling them methods, not functions. You will understand why in a while. But anyway, so you have one method called to calculate a grade and one method to display exactly the same thing. But they are all bundled inside this class called student. So what happened outside this class, we just create or instantiate actually an object of the class. We call it a student. We give them a name and score, and all what we have to do just call the student and request the built-in method that within that class. Now, what differentiates this from this? Actually, you could see that now this student that we created, Dennis here, it has its own properties of name and score, and it has its own method bundled or inside the object, which we call it Dennis now, or the student. Completely different kind of ideas, but actually the outcome is going to be identical, the same. And that what differentiate actually procedural from object-oriented, from coding, image or perspective. Both of them doing the same thing, but you could see this one is bundled inside the class. This one is just put in a form of a procedure or steps 1, 2, 3. Here, the functions are completely independent. Here, the functions are completely, or the methods now, I should say, are completely bundled for each object that is instantiated. Now let's look at some of the comparison in terms of features. So if we take the first feature actually called the way we organize the code. In procedure programming, we organize in terms of functions. So this what differentiate the word from object-oriented. We call it objects and class. This is very important way of looking, as we said, here functions and here objects and class. The next, actually, in terms of the access to the data, we saw now every time I need to access to the student created in procedure programming, it's going to be kind of a global access, but in object-oriented, it will be encapsulated. Each kind of object has its own method and its own attributes. This actually abstract or theoretical writing will be clear as we are moving along the course with the practical example. Now for reusability, believe me, procedure programming, it's very limited. If I write one script, I could hardly say it can be reused again. Unlike in object-oriented, it's highly possible to reuse the script that you wrote in form of a class and etc. Using what's called inheritance and polymorphism, which we will talk about it later. In terms of security, of course, when you have your data or the attributes or the values are globally accessed, that will be less secure. But in object-oriented, you bundle everything inside this black box we call an object, and it will be absolutely much more secure. And from the idea of a real-world modeling, you will see that procedure programming represents kind of an abstract step-by-step, but object-oriented really can simulate what's so-called a real-world inspired case, that every object has its own kind of existence with method and attribute. Last but not least, in terms of maintenance, believe me, procedure programming, I have a good experience with that. It really get harder to maintain and make corrections, etc. once the code get longer and longer. Unlike object-oriented, it's really easier to debug and proceed more. So these are the two differences between these two paradigms for some people who focus only on object-oriented from programming perspective to see the difference between these two different kind of languages we use. One of them is using procedural, one of them is using object-oriented. Now we are ready to move to the next outline is to discuss what is exactly object and class as I have illustrated in the previous code. That's exactly what we're going to do next. I will see you then.